Triple fact. Unleash your curiosity.
Whether it's your new natural deodorant that you switched to, or maybe you forgot to take a decent shower for a couple of months. It's puzzling how we lose our ability to detect our own smell, while others can. This is a phenomenon called olfactory adaptation. The olfactory system is one of the world's best difference detectors, and that's how it was designed. It can detect more than 1 trillion distinct scents, but since the olfactory system is bombarded by an extraordinarily diverse range of smells. And because every object in our environment has its own distinct smell, it will be a nightmare for your nose. So in order to maintain high sensitivity yet avoid most of the unimportant odorants around us, we must possess some means of adjusting the response of their olfactory system. This process is known as adaptation, and is a common feature in all sensory modalities like hearing and vision. Every object in our environment gives off scented molecules. When you inhale, the molecules pass through your nostrils and stick to a wall of mucus located on the nasal cavity. That mucus is home to receptor cells that tell your brain what it is you've just sniffed. What seems to happen if you kept smelling the same thing for a long time, is that the receptors that would normally respond to the smell almost turn off after being bombarded for so long with the smell. It's like if they get bored smelling the same thing over and over. That's where more long-term loss of sensitivity comes in. Over time, even if the receptors in your nose pick up on a smell, your brain might start filtering it out as useless information. But sensitivity recovers over time in the absence of further exposure. For example, if you're surrounded by a pile of cheese, over time you won't be able to smell it, and the intensity of the smell will decrease the more you stay around the cheese. But if you visited a friend or took a long walk, your nose will be able to pick up the scent of cheese again, a process known as recovery. And since you can't get away from your own body, there's no way for your nose to regain sensitivity to your own smell. And that's why the smell is even stronger to strangers, because your smell is always something new for them to discover. This may sound as a disadvantage, but if your sense of smell was bogged down by your body odor or other standard smells, you might not be able to detect the more important odors, such as ones that might alert us to danger, like something burning, or something good to eat like that Moroccan tagine. A property of olfactory adaptation is that adaptation also reduces the perceived intensity of an odor. A phenomenon that can be observed after even a few breaths of an odorant. For example, a Drosophila larvae placed in the center of a petri dish, on which a disc impregnated with odorant and a disc impregnated with water have been placed diametrically opposite one another. Drosophila larvae are responsive to most, if not all, odorants that have been tested. In their unadapted state they will readily crawl to the disc with the odorant. However, after a while, they will distribute themselves randomly on both the odorant impregnated and the blank disc. Not losing all their sense of smell, but rather experiencing a reduced intensity of the smell. Another property of olfactory adaptation is cross-adaptation, which means adaptation to one odor may generalize to a small subset of other odors that share structural or perceptual features with the adapting odorant. For a simple conclusion, olfactory adaptation simply means, the more you're surrounded by a smell, the more numb you'll become to that specific smell.